Hello everybody, this is the third video in the Securing Windows series. In this video we're going to be looking at the rule title of Windows 11 systems must have UEFI firmware and be configured to run in UEFI mode, not legacy BIOS. So let's take a look at how we can determine if our system is compliant. So let's dig into that real quick. So again, this is the STIG. That's the rule title I just explained, and let's talk about this. So the UEFI provides additional security features in comparison to legacy BIOS firmware, including secure boot. As you remember from videos 1 and 2, as we move up to these different controls, these ones are also talking about secure boot and credential guard. Now this one right here is talking about credential guard, the one over here, and of course secure boot. And then the reason for having Windows 11 Enterprise Edition is, again, so you can use credential guard, and therefore you're going to have secure boot. So all three of these right now are in a string collection in order to support credential guard and secure boot. So it's a good idea to understand. So how do we check? So for virtual desktop implementations where virtual desktop instances is deleted or refreshed upon log off, this is not applicable. So again, if you're using something like vMotion or some other type of VDI, this would be not applicable. So let's verify if my home system is running UEFI. So I'm going to run system information. So I'm going to click the start button down here. I'm going to type in system information. Okay, we'll click that right there. It's going to pop up, and I'll minimize this real quick. What do we got here? And what does it say? It says under system summary, so system summary on the left, if BIOS mode, so system summary, we'll find BIOS mode over here, does not display UEFI, this is a finding. So let's find BIOS mode in here. So right here is BIOS mode and UEFI. So I'm running it, I'm compliant. So that's a good thing. If you're not, then what does it say? It says configure UEFI firmware to run in UEFI mode, not legacy BIOS. So you would have to go into your BIOS and enable UEFI mode. And again, just do a search for your user manual for your BIOS, or I'm sorry, for your motherboard, and it'll walk you through the steps and do a search for UEFI. It'll say, oh, go here, 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 and you can enable UEFI. Typically, organizations will do this prior to installing the operating systems. You never know what's going to happen if you switch from BIOS to UEFI. You could screw up your entire operating system. So always plan to do this ahead of time. That's why it's very important when you're doing secure host baseline builds of operating systems, or you're introducing new hardware such as a server or physical desktops, that you always want to address the settings inside the BIOS to make sure they're as secure as possible before you go to install operating systems. So definitely research that. So I'm going to go ahead and close this here. We're not going to need it again. And then that right there is going to meet the CCI requirements. But before we get into that, let's talk about UEFI and why it's better or different than BIOS. So I pulled up an article here that I thought was pretty clean. So on How to Geek, this is by Chris Hoffman and Nick Lewis, and it is what is UEFI and how is it different from BIOS. Now they don't go into every single thing here. You can do searches across the internet and you can find different articles talking about different components and stuff like that. So the good thing is to definitely go through and do some research, just like anything else. So when you're tasking your analyst or your engineer to say, hey, we'd like to do UEFI, what does that mean? Or we're trying to do credential guard, what are the dependencies? And we say, well, Windows 11 Enterprise, Trusted Platform Module, and now we have, of course, UEFI. So they all work together, and the key takeaway is important. So UEFI is a modern replacement for BIOS. Faster boot times, larger hard drive support, and user interface and backwards compatibility with older BIOS systems. UEFI behaves similar to the operating system, and it offers secure boot networking capabilities that were absent in BIOS. So basically, you can run commands while you're in UEFI. You can have network access to UEFI while it's on. So definitely different than BIOS. I would encourage you to read this. Well, let's go down to some things here. I'm not going to get into too much detail because again, you need to research what you're doing before you're going to do it and understand the differences. I cannot think of any reason not to upgrade to UEFI. I mean, there's reasons, but all my machines at home have UEFI enabled, so that's just what we did. So right here, the old BIOS, you can only boot from drives that have 2 terabytes or less. So with UEFI, you can boot from a drive that has more than 2.1 terabytes. 8 terabyte drives are now common. So that's a good thing. The BIOS runs in 16-bit processor mode, and with UEFI, I think they switched that to 64-bit. It doesn't say it on here. The interface, of course, for BIOS is relatively old. But again, if you're looking for settings, interface shouldn't matter in the long run. It's like, how do I get from point A to point C? If I had to click a couple buttons, whatever, I'm there. So, but this does provide a UI, and some of them even allow you to move your mouse, which is weird, but okay. And let's see, the improve the BIOS. So we already talked about the drives. 2.1 or larger drive can be supported by UEFI. Oh yeah, right here. So it can run in 32-bit or 64-bit mode. Then let's see what else we got. So the secure boot is really the biggest thing we're looking at here, because with secure boot, it's all about drivers and the way it loads the operating system. If you don't have signed drivers and you try and you enable secure boot, it's not going to turn out well. So the best thing to do is make sure that all the drivers that you're installing are signed, which these days, if you're a reputable business such as Microsoft or Intel or AMD or other organizations, they typically digitally sign their drivers, their driver files. So that's good. But again, I mean, there's tons of these articles on here. I think the most important thing here is to talk about the RMF control. It's the same as the previous one for Trusted Platform Module. It's SC8 Enhancement 1. So as we see right here, SC8 Enhancement 1. Here's the control correlation identifier. And if we go down here into the Enhancement 1, again, the information system implements cryptographic mechanisms to prevent, Y, and then during transmission, otherwise protected by blank. So we do that during transmission. That transmission will be the boot up process, which is great. However, the encryption that's happening and the cryptographic mechanisms of secure boot, they resolve and meet the requirements for this. So again, when you're writing your plans and procedures or your subsystem design documentation, you can basically take this text here and says, well, we're enabling UEFI across all of our hardwares, all of our physical systems. Why? To provide additional security features in comparison to legacy BIOS, including secure, So basically, you're just taking the discussion, reversing it into what you have committed to do, and now you've answered that question. And then when you run these STIGs against your systems, when they come back as compliant or non-compliant, that tells you, it says, well, I'm running, on some of these I'm running it, and it's good. On these others we haven't, and you say, well, the reason why is because those were originally loaded with BIOS, and we haven't done a rebuild or an upgrade. And of course, when we do an upgrade or a tech refresh, when we introduce our new system, we will make sure UEFI is enabled, just like you had said in your plan, by copying this statement and reversing it to this is what we do. So the secure boot function again is the reason why we're doing all this, in order to secure to do the virtualized base security or VBS and the credential guard. So that's it. I mean, so we'll get into the next STIG in the next video. And again, if you have any questions, just send me a question in YouTube or Rumble or whatever it is, and I'll be more than happy to answer. I'm itching and waiting for the questions. So just let me know. All right, thanks.